All right, today we are going to be talking about water and its different states of matter. And there are three different states of matter: solid, liquid, and gas. For solid, there are two different kind of variables that we have to include in here. We have to include kinetic energy and we have to include attraction. And today we're going to be explaining how solids, liquids, and gases each have different kinetic energies and different attractions. And so for a solid, we have a low kinetic energy because it's not really moving that much and it's really low in degrees. It's really cold. And it has a high attraction because you can see all the molecules are together, is this real world example. And in degrees, it's represented as 273.2 degrees Kelvin or below. But if you get low enough, the rules of matter just. And so for liquid, we have medium kinetic energy and medium attraction. It's bad represented drawing example, but Kai, would you like to do the honors? So, that just shows how, yes, the molecules are beginning to separate apart, but they still have enough attraction to become one. And so in degrees representation, 273.2 degrees Kelvin as the solid, but to between, and the maximum being 373 degrees Kelvin. So for gas, we have a high kinetic energy because those gas molecules are moving around so much, and we have a lot of repulsion. They can't come together to make a solid, so they just stay in a gas form. Kai? Yeah, all right. And so in a temperature representation, 373 degrees Kelvin or equal or higher. And this is all talking about water. Remember that, water. And let's see, we have to talk about the, you know what?
Shape, volume?
Yes. Okay, yeah. Yeah, volume. So, being this, it's not considered like being in a state of volume. It's more like a state, like a solid. It's a definite solid. It's definite shape, and it's an indefinite volume. And for a liquid, it's a definite volume, but an indefinite shape, because liquids usually conform to the shape they're in. Say if they're in a cup, they conform to the shape of the cup. So, and for a gas, it's just no volume whatsoever. It's like no solid whatsoever because the molecules can't come together, and it's a volume because it takes up space.
All right, so indefinite volume, indefinite space for shape for gas, right?
Well, it should be, yeah, because the molecules can't come together to make some sort of
But it is a definite shape and volume for a solid, right?
Yes.
Okay. All right.
In liquid, it's mismatched. It's the middle.
Well, I think they did a wonderful job. What do you guys think?
Woo!
Yay!
Any questions from